So we have these tree ferns and things like that that can stick up out of the ground much farther than any moss can because it has that vasculature. But they still have this limitation that they just drop their spores out, right? They have these little dots on them. What are those dots called? Sporophylls, which are the spore-bearing leaves, have these little spots where an inducium covers several sporangia, and then when that sporophyll is ready to drop spores, it opens up that inducium and releases spores from its sori. Sori. The answer is sori, right? Okay. So here we see these dots there on the bottom, and those are the sori. Here we see the inducium covering the little sporangia. Right? So, all right, so here are all the sori ready to drop spores, and that's a major limitation. So you might have ferns, you might buy a potted fern, and you might keep it alive for 20 years, and you might never see it have a baby. Okay, it might, send out its rhizome and send up new sprouts, send up new leaves and stuff like that all the time, but it'll never actually manage to go through the actual process of sexual reproduction and complete its life cycle and have a baby. And the reason for that is because, unlike plants that drop seeds, these guys just drop spores, so the conditions have to be just right for those spores to germinate and do anything useful. And so we see, plants have alternation in generations, right? They have a sporophyte phase and a gametophyte phase. You saw that in the moss that had that green gametophyte and that little brown sporophyte, right? The sporophyte was very simple, very early and primitive. It didn't have a lot of advancements or anything like that, but we're going to find that as the plants get more complicated, it's going to be the sporophyte that's going to get all those advances, right? So eventually, that little sporophyte develops into a vascular structure that grows all these green leaves, and eventually it can move out of home and support itself. It's always going to get its start from mom, because that's part of the definition of what a plant is. So here we have a gametophyte, and it's made a little baby, and here comes the sporophyte coming out of it. And you can see the sporophyte looks different than the gametophyte, because the sporophyte is vascular, right? The gametophyte is translucent, because it's just a sheet of cells, a sheet of green cells. And right now, she's paying the rent, as it were, for this creature, right? But when that creature gets a little bit bigger, this thing's going to actually outlive her. And this thing's going to become entirely self-sufficient and be able to photosynthesize for itself and support itself as it grows into one of those nice, big, bushy ferns and everything like that. But to complete their life cycle, they do have to make one of these, which will develop Antheridia and Archegonia, and those will make what? Well, what do they produce? Antheridia produce?
Will produce the eggs of the oocytes.
No. Sperm. Antheridia produces sperm, right? Keep the notions of sperm and pollen separate, because they are separate, right? The pollen is actually the evolutionary derivative of this entire thing, right? Or at least the bit with the Antheridia. So we got Antheridia and Archegonia. The Archegonia are going to produce eggs, right? Because this is the gametophyte, and in alternation of generations, gametophytes make gametes and sporophytes make spores. Remember, they have different ploidy levels. The gametophytes are haploid, the sporophytes are diploid, right? So the haploid gametophyte produces these haploid spores and everything. And, okay. Fertilization occurs. When fertilization occurs, you have the fusion of the egg and the sperm. You're going to create the zygote. The zygote's going to be supported by the gametophyte until it's able to support itself and everything. And then the sporophyte's going to make more spores, which germinate into more gametophytes. That's the cycle of life in plants. Okay, so after these simple vascular plants, what's the next thing we develop? We've got ferns and stuff like that, but then to move on evolutionarily, we have a more complex group. What's that group?
Seed-bearing.
The seed-bearing plants, the spermatophytes. And the first group of seed-bearing plants is what? The gymnosperms, yeah. So we have gymnosperms like this, and like pine trees and stuff like that. The cycad here has a nice big cone, although it's not really a conifer. We'll see that later. So we have these things now. This is the sporophyte, okay, and the cone is going to produce megaspores and microspores, right? The megaspores are the female spores. They're going to form into megagametophytes, and the microspores are going to form into microgametophytes. We've seen a general trend towards a shrinking and a simplification of the gametophyte, right? So by this point now, the microgametophyte, the male gametophyte, has been shrunk down to the point where he's like a couple of cells, and he's actually microscopic and can actually just blow on the wind, right? So the male, the haploid male microgametophyte can just blow on the wind and get caught by the female's ovulate cone, like on a pine tree or something like that, right? So here's a pine tree's ovulate cones. So this is the sweet, sweet goal of that pollen that gets blown out everywhere, right? Show pollen cone. Okay, so the gymnosperms produce a ton of pollen, right? Here you see it just smoking out of that, right? Like if hit by any breeze or whatever, these things will produce masses and masses of pollen. And this is the goal, right? They want to hit this so that that pollen will stick to that and be able to fertilize that at a later date, in about a year. Within that structure, which is a sporophyte structure, deep within that structure is located the female megagametophytes, right? And the megagametophytes, they're going to make what? Gametophytes make gametes, right? The female megagametophyte's going to make what? The eggs, right? So this is a sporophyte structure, but within this, there's some female structures, right? And within those female structures, those females are going to make the eggs, right? So the pollen wants to get here because the pollen wants to be able to produce sperm to fertilize those, right? So it's going to grow. If it gets to that, it's going to grow in towards that and produce a sperm to fertilize the egg. So that's how that works, right? So the gymnosperms include, cycads and a bunch of weird plants, and then all the conifers, right? Like the larches and spruces and fir trees and pine trees and junipers and cedars and all that kind of stuff. All right, so they produce a ton of pollen. It goes everywhere. It goes on your driveway, in your car, into your lungs, and everything like that. And only a tiny amount of it ever gets to this, to the goal, right? So that drives the next evolutionary advance, which is what? Flowers. Flowers and fruit, okay? So from just spraying pollen everywhere in hopes that you hit this, well, that might work if you're a pine tree in the taiga, because if you're a pine tree in the taiga, you're surrounded by other pine trees. So if you drop pollen and it blows in any kind of breeze, it's going to hit some other pine trees, right? But what if you're like, one of the only ones of your kind in the forest, right? What if you're like, something like, I don't know. Yeah, what if you're like a Solomon seal or something like that in the middle of the forest, and there might not be another Solomon seal right next to you or whatever. So you've got to, get your pollen to another plant, but it's not right next to you. So if you just blow your pollen out randomly everywhere, you might not hit another one of your kind, right? So you need a guidance. You need some way to get your pollen through the forest, guided to that other Solomon seal that might be far away, or that other plant, or whatever kind of plant it might be. A lady slip or something like that. So we get the development of these very complicated structures, the flowers, and the flowers are a way where plants, in many cases, plants use flowers to induce animals. Plants don't have muscles, plants don't have brains or anything like that. It would be very difficult for a plant to evolve the machinery needed for part of the plant to fly off and go find another flower, and attach itself to that. But animals have that already. So if we simply evolve some kind of landing pad and some kind of reward, and maybe some colors to differentiate it so that the animals can recognize it, the animals will come and fertilize these different flowers. So we have this wide variety of flowers, that have all kinds of crazy shapes and everything like that. Like the flying